Do you like doing the same thing over and over again? Like copying and pasting the same piece of R code many times into your script? Well, then this video is not for you because we're going to learn how to write functions, which allows you to write that code once and move on with your life. Cue the music. Okay, we are back in our studio. This lesson is about writing your own function. So why would you want to do that? Basically, a function is a snippet of code that you can save and give a name and reuse that snippet of code over and over again so that you don't have to be writing the same piece of code more than once. So this is all about working smarter and not harder. It allows you to write less total code because you don't have to repeat things over and over. And it has the added benefit that when you write your own function, your code is going to be easier to maintain and more reliable. And we'll see examples of that. And what we'll cover today is how to define and call your functions, the different parts of a function, and the important concept of variable scoping. Before we get into that, we need to have a data set to work on. The data set we're going to work on is a data set that consists of a bunch of flights from one day. I have that data set here. I'm in the video code directory, working off a file called functionscode.r. You'll also have access to functionscomments.r. As usual, I encourage you to open up functionscomments.r and type in the commands as we're going through them in the video. That's going to be the quickest way for you to learn these concepts. So in addition to those two files, there's a new data set called Airline 2019-0701. I have links to all these in the description, including a link to where I got the data. So this is this airline data set, but as you can tell from the name of the file, it's just flights from a single day in 2019. All right, so let's read in that file. So we know, let's call it air, and we know to get to that file, we have to go up one directory, back down into data sets, and it's called Airline 2019. And I can, since the theme is working smarter, not harder, I can type AIR tab, and it will complete it. Close quote, close parentheses, control, enter, sends it over to the console. As usual, the first thing we like to do when we read in a data set is find some way to look at it. Usually the first one I do is str, just to get a handle on which variables are there. So if I make room for this, you can see there's a whole bunch of different columns. The different variables are things like year, quarter, month, flight date. As I said before, the data set, in the data set, each row is a flight. And this data set comes from a larger data set of many years of flight data. But I've gone ahead and subset it to one day to make things a bit simpler. So things like year, quarter, month, and date are all going to be the same throughout the data set, but I've left them in there. Some important variables. One is tail number. That's a unique identifier for each airplane. There's a bunch of information about the origin in different formats. So there's an airport ID. There's an airport code that's in origin city name. And then there's corresponding information about the destination, information about delays, other information about timing, and then all kinds of the same information about arrivals as well. We'll also be looking at distance. So that's just a preview of what's in the data set. I'll also do head, air, and that will print out the first 6 rows. You can see what I mentioned before. All these are going to be the same throughout the data set. Airline, these are the plane identifiers. information about origins, destinations, so on and so forth. And this was in str, but let's just do dim air to get a handle on how big the data set is. So it says 20,577 rows, 69 columns. I'm not an aviation expert, but I guess that sounds about right. It's a large number of flights in one day, but we have a big airline system in the US. So maybe that sounds about right. The other thing is that this is only flights in the United States for that day. In this lesson, we're going to be printing out information about the flight paths for individual tail numbers, individual airplanes. And to do that, we're going to have to figure out for a given tail number which indices in the data set correspond to that tail number. So we're going to start with a short lesson on indexing here. So I'm going to define a variable called tail number. And to grab a tail number, I'm going to grab, let's do this one, 303NV. So I'm just defining a character string 303NV, assigning that to tail number. And then I want to select the indices in the data set that correspond to that tail number. So I'm going to define II is a vector, air dollar tail number equals tail number. Okay, so this thing is the variable we just defined right now. Well, it's going to be equal to 303NV. This thing is the column tail number in the air data set. And I'm separating them by the equals operator. So this is going to test for equivalence between each entry of this vector and the value tail number, which is set to 303NV right now. Oops. So if I run that, we'll see that see if you can guess what this is going to be. Type of II is logical. This will return a logical vector. And length of II should be the same length as tail number. And it's going to be true if the corresponding element of tail number is equal to this tail number and false otherwise. We can actually count up how many there are. If we do sum II, we get 6. So that tells us that there are 6 trues in this vector, which means that this particular tail number has 6 flights in the data set. Now I want to print out the information about this tail number. So I don't want to print out all the variables. I just want to print out a few that I'm interested in at the moment. So I'm going to do departure time, arrival time, origin, city name. Oh, and I forgot a quote there. The reason I forgot a quote is this was black instead of blue. RStudio will give you little hints that you've made mistakes. Dest, city name, and let's do tail number 2 just to convince you that we've grabbed the right thing. So those are the variables we want, and I'm going to print out those rows that correspond to this tail number. So I'm using II, and the columns we just selected. So air is a data frame. I'm using single square brackets to index it. To get the rows, which is the stuff before the comma, I'm using a logical vector. To get the columns, I'm using a character vector with the names of columns. So that will print it out. So you can see the 6 flights here. This one, for example, started at 6:34 p.m. This is in 24-hour time or military time, and ended at 8:41 from San Diego to Eugene, Oregon. And the first thing you probably notice is that these are out of order. The first flight in the morning for this airplane was at 6:10 a.m. From Las Vegas to Austin, but that's the 4th row. So in order to facilitate printing this out in a nice way, what I want to do is reorder this data set. And there's different ways of doing that. I'm going to start with you might consider this a more roundabout way, and then we'll get to a more efficient way at the end. But here's the roundabout way. So I'm going to define a new data frame, air this tail, is just the subsetted data frame for this tail number. So if I do dim air this tail, this should be 6 by 69. And if we want to look at the departure times, we can do it a few different ways. Dep time. Those are the departure times. So I want to use these departure times to reorder this data frame. And of course, you can use sort to sort them, but this isn't really going to help us. This will tell us what order they should be in. But what we need to do is reorder the whole data frame. So we need to use this information to figure out what order they should be in. And the function for doing that is called order. So if we say order air this tail $dep time, it's going to return a vector of indices that tells us what order they should go in. So what this is telling us is if we pick the fourth one and put it first, that one's going to be in the right order. So this is the order. This is ordered by departure time. So what this is telling us is we should order them number 4, which is that one, then number 6, which is that one, then number 5, then number 2, then number 1, then number 3. So that looks like the right order. So I'm going to assign this to a variable called ord, and I can type air this tail ord, and let's just grab the variables we care about. Oh, I didn't run that. Okay, so that's the reordered data set. I don't like how this is printing out because I don't like these row numbers over here. So I'm going to use the print function, which allows me to say row.names equals false. Okay, so now you can see it starts at 6:10 to 10:49, Las Vegas to Austin. The next flight started at 11:30 from Austin to Las Vegas, so it went back. The next flight was 12:58 from Las Vegas to Eugene. And then at 3:50, it went from Eugene to San Diego, then from San Diego to Eugene, and Eugene back to Las Vegas. I guess ready for the next day for the 6:10 flight the next day from Las Vegas to Austin. Okay, so that's the reordered data set. All right, now I'm going to show you a different way of doing the same thing that's a little bit more efficient. As we'll learn later, creating new data frames, for example, like this, can be an inefficient operation in R. So we're going to redo this to print out this data frame in a little bit faster way. Because this could get to be computationally burdensome if we're doing this lots and lots of times on a much larger data set. Okay, so I'm going to, again, define II, but I'm going to do it a little bit differently. So air $tail number equals tail number. So this is the same code as before. This will return a logical vector. But if I surround a logical vector by which, it will convert that logical vector into just information about which indices are true. So if I do that, let me just show you what it gives you. It gives you the 6 indices in the big data set air that correspond to that tail number. In other words, it gives you the 6 indices in that big data set for which this evaluated to true. And of course, we can use index numbers instead of true false to subset air. So let me just show air II. Now these are numbers instead of logical vectors and vars. So that does the exact same thing. So we're good there. But what we need to do is reorder these indices to get the right thing. So the code to do that is the following. I'm going to define a variable called ord. And it's going to be these indices II, as you can see here, but in a different order. And the way I'm going to order them is, again, with the order function, air, dollar, dep time, and I'm going to select the ones that I want, II. All right, so this is a bit of a complicated operation. So let's take it through step by step. These are the indices. These are the indices. These are the departure times for those indices. This is a reordering. This is the same thing we saw before. But now I'm going to apply the reordering to the indices and not to the whole data set. So if I do this, I'm applying the reordering to II. That gives us these original indices II, but in the right order. And I'm going to assign that to ord. And now I can just type air. I don't have to create a new data set. ord bars. And that should work how I want it. Okay, so this is a bit simpler code. And like I mentioned before, it's going to be more efficient if we're working with really big data sets. And I'm going to do row.names equals false. Okay, so that prints the information for tail number 303NV. Now, if we wanted to do this again for a different tail number, we can just repeat the code. So I'm going to take this code, copy it, and then I'm going to look back at head of air to get a new tail number. So went too far, right here. Let's do 336 NV. And maybe I also want to do it for the next one. 218 NV. Okay, so this set of code, these lines, will print information about these three tail numbers. Okay, so that's the information. But as you can see, we're just repeating the same code. The only thing we're changing in each block is the tail number. Other than that, we're just repeating the same code. And that's the exact situation where you should look at your code and say, hey, I'm writing the same line over and over. I should just write a function to encapsulate this piece of code in one object so that I can call that function with different tail numbers and not have to write the same thing over and over again. All right, let's do it. And this is really, really easy. So I'm going to define a function. I have to give it a name. So I'm going to call it flight path. And I'm going to be doing this over and over with different kind of variations on how we define the function. So I'm just going to call this flight path 1. So this is just a regular assignment. And the thing I'm assigning to flight path 1 is the output of the function. And function is a special function, and R is telling you that because it's turning it pink or purple there, whatever you want to call that color. Inside of so the arguments to the function are going to be the arguments to your function. So I'm just going to give it one argument called tail number, and I'm going to close it. And actually, let's do something simpler first. Okay, so I'm going to give it 0 arguments. And then after the arguments, you do curly braces. So this is indicating that we're going to give it a set of R commands or an expression. And then you just put the code in there that you want to put in there. So I could put this in there. All right, that's my first function. And so to execute the assignment of this to flight path 1, same thing as always, just do Control Enter. And now we can type in here flight path 1. That's our function. So this is a different type of object. If you do class flight path 1, it's a function. Okay. And then we can call it flight path 1. Remember, we use curly braces to call our function, just like any other function, and it will run. And we can change the tail number. Call it, run it again. We get the data for that tail number. Okay, so what's happening? When we call the function right here, flight path 1, it executes this code. So it's going to do this assignment, same as we did before. It's looking at the air data set. It's looking at the tail number column in that data set, the tail number variable that we defined. Defines this by reordering according to the depth time column in air. And then it prints it in the right order with the right variables, namely these variables. Okay. And then when we change tail number and rerun the function, it looks at this variable and says, what is the new tail number? And then reruns all the same code with that tail number. Okay, this is much better than before. Now we got 4 lines down to 2 here to call it. But we can actually do better. So I'm going to change this function flight path 1. I'm going to give it an argument called tail number. And this is going to be our first lesson in variable scoping. Okay, so let's rerun this. And if I try to call this again, I think I'll get an error. Okay, error in which blah, blah, blah. Argument tail number is missing. So we redefined the function flight path 1 to have an argument called tail number. So when we call it without an argument, we're going to get an error. So I'm going to put in a tail number here and delete this stuff. Okay, now it works. So what happens here? When it's executing this line of code, there's a few variables it's looking for. It's looking for something called air. And this is how it looks for it. It looks to see if that variable air was supplied as an argument to the function. If not, it will look in the what's called the enclosing environment. So it kind of looks at all the other variables that are available, and then it grabs that one. So it doesn't see air as an argument, so it grabs the value of air from outside the function. All right, then it goes on, does a double equals, and then tail number. Now here's a situation where we have tail number as an argument, but we also have tail number defined up here as just a variable in our global workspace. So what it's going to do here is it first checks whether this is an argument to the function. If it is, then it's going to use the value that was supplied to the function, which in this case was 303 NV. Then it moves to the next line, does all the same stuff. It sees air, which is not an argument to the function. It grabs the one higher up in the global workspace, so on and so forth down the chain. So if we want to change which tail number we're looking at, we just change the argument to the function and call it there. So it's printing out the other information for the other tail number. And of course, everything's in order because we told the function to reorder stuff. Okay, now this is much better. We've got 4 lines up here down to 1 line each down here. All right, so that's the beauty of the function. because it makes your code a lot shorter. You'd have these 5 lines to define the function, and then anytime you want to use this code, you just call it like this. So this is much nicer. The other thing that's really nice is, suppose you had a big script with a bunch of these things in it, and you decided you wanted to change something silly, like you don't want to, like you do want to include the row names for whatever reason. What you would have to do is go through and in each of these delete that, then delete that, delete that. Say you had 12 of them, you would have to go delete each one. If instead you had written your code by using a function and it looked like this, where you define the function at the top and then you call it a bunch of times, you would just have to change it in one place. You just have to remove this here and then rerun the code and everything would be fine. So that's why we say that using functions when you're repeating code makes your code much easier to maintain. So if you want to make a change to it, if you're writing things in function, there's only one place where you have to make the change, as opposed to if you weren't writing functions, just repeating things over and over, then you'd have to change it multiple times. And it's easy. It's also more reliable, because if you're doing that, changing it everywhere in your scripts, it's easy to make mistakes, and then you get errors and bugs and everything goes wrong. So life is easier when you write functions to encapsulate code that you're going to be repeating in your R script. Okay, let's do a variation on this. I'm going to take this function, copy it, and go down here. So the comment here is forced user to supply a data frame. So there are two main objects in here, air and tail number, and I'm only supplying tail number as the argument, but you can do multiple arguments. So I can say, I could put air here. So now, and I'm going to call this flight path 2. So this is a new function called flight path 2, which takes 2 arguments, air and tail number. When this gets executed, when it looks for the air object, it's going to first look for air as an argument, and it's going to see that air was supplied as an argument. And it'll use that one instead of a version of air that was defined outside the function. All right, so let's call this function flight path 2. And let me show you what happens if you don't supply air. Oh, that's a different error. I didn't run this line. Okay, so now we have flight path 2. And it says error, argument air is missing with no default. Okay, that's what we expected to see. Now I can supply the air data frame as the argument, and it runs it just fine. So this is the tail number, and this is an object, air, in our global workspace that we're supplying as an argument to a function. So it's doing the exact same thing, but now we're forcing the user to supply the data frame. And what could happen is, so say we had a different data frame called flight DF. Here I'm just setting it equal to air, but you can imagine this is some other data frame, maybe from a different day. We can supply flight DF as the argument. In this case, it's going to give the same answer, but this will work as well. So even though this is called air, if I supply flight DF, it's actually going to use the data in flight DF. This is going to get assigned to the variable air inside the function, and it's going to use that one. All right, so here we're using a function to execute 3 lines of code, which at the end prints something out about this data frame. But usually people write function to return things, and all functions will return something. So I'm going to create a new data frame. I'm going to call it flight path 3. Right now I'm going to not change it at all, so let's see what happens. And I'm going to call flight path 3 on our default tail number. So run this, call it. You can see it still prints out the information there. But I've also assigned the output of flight path 3 to just a temporary variable. This is the name I typically use for a temporary variable, SV for save. And Control 2 will send me to the console, and I want to look at this thing. Okay, this is the object. So by default, what's happening here is a function will return whatever is evaluated on the last line of the function, which is here. What's kind of interesting is that you may not know this, but print actually returns something. So if we say save is print, let's just say 1 to 10. It will execute the print, but it also assigns the output to save. And if you look at the documentation for print, here, okay, this is saying that print is a generic function. I think, all right, does this say? Documentations are supposed to have a value section which says what it returns. Let's try print.default. I'm looking for what the print function returns. Arguments, details. I don't see a value section. Okay, so somewhere it must be documented that the print function returns the object that it's printing. I don't see where that is. I'm sure it's somewhere. If you know where that is, let us know in the comments. But print actually returns something. That's a bit of a digression. But so what's happening here is the last line that gets evaluated on this thing returns the object, air, ii, ord, vars. And so what gets returned by this function flight path 3 is this thing. And what you can see what's happening on this line of code is we're assigning the output or the return value from flight path 3 to the variable save. And you see now it's available to us. Okay. All right, so that's our first lesson, that even though it doesn't look like this function is returning anything, it actually is. We can get the same behavior if we just got rid of this. So this should return the same thing, I think. Yeah, that's the same thing. However, when we call flight path 3, it doesn't print anything out. That's because we don't have an explicit print statement in the function. So functions are similar to for loops in that if you want the for loop to print something inside of the loop, you have to explicitly say print. Functions are the same way. So if you don't explicitly include print inside of a function, it won't print anything, even if you include a line like this, which would normally print something if you're outside of a function or a for loop. Okay, let's have it return something a little bit more useful. So I still want to print. So let's keep that. But I want to return the indices because we might want to use those. So we give it a tail number and we might want to use the indices for something else. So this new function, flight path 3. Actually, let's make a new function. Let's call it flight path 4. So we're still going to print, but I want to return ii ord. And we'll say this, we'll call flight path 4. Okay, so let's analyze this function. Same stuff is happening here. We're going to print, and then what gets returned is whatever's evaluated on the last line. So let's define the function, call it, so that prints, and then look at what's in save. Now it's returning the thing that's on the last line, namely II ord. So these are the indices in the original data set air, which correspond to the tail number that we provided. Now, it will automatically return this if it's evaluated on the last line, but I think it's good practice to actually explicitly put the thing that you want to return inside of the return function. So this does exactly the same thing. So this is just a style preference for me that I like to explicitly say in the function what I'm returning by using the return function. So this does the exact same thing. Okay, now what if you decide, okay, I actually don't want a function to print anything. I want a function that just gives me the indices. So let's copy this. Let's call it flight path 5. And so the obvious way to accomplish that would just be to delete that line. If we delete that line, what's going to happen is we'll define II using the supplied tail number. We'll reorder, and then we'll return the reordered indices if we were to delete the selected line. However, maybe some people want it printed, some people don't. So you might say, okay, I'm going to supply a second argument. I'm going to call it print flight path or print path, and I'm going to give it a default value. So now when we run the function, even if we don't supply this print path argument, it's going to evaluate to false by default. And we're going to use it here. So I'm going to say if print path, then run this line of code. And now we're getting a lot of lines here. So let me add some spaces just to make this easier to read. Okay, so here's flight path 5. What this function does has two arguments. First argument is the same as before, but now there's a second argument, print path. And this is going to be a logical. If it's true, it will execute this line. As you remember from our module on if statements, if it's just one line that's the expression to be evaluated whether or not the thing is true or false, you could just put it on the same line without curly braces. So I'm using that feature there. And then at the end, whether or not I print this, I'm going to return the ordered indices. Okay, so let's see this. And okay, flight path 5. So if we call this, what happens is it's going to set tail number to 303 NV inside the function. And there's no specified print path variable. So it's going to choose the default value of false. And when it gets to this line, it's going to see that the stuff inside if is false. And so it's going to skip this and it's just going to return the indices. All right, so let's run that. Nothing happens there. But we have assigned the ordered indices to save. Now, if we want to do this again, we can say true here. Now this prints it out. And it's the same thing in save. We could also, as we learned before, we can give it the argument names. If we wanted to be really explicit, we could do that. That just does the same thing. Probably don't need to if there's just two arguments and you're using your own functions. Up till now, we've always been printing the same variables. And the way that happens in this function is there's a variable called vars. Now, just to remind you how the variable scoping works. Okay, it's looking for a variable inside the function. It's looking for a variable named vars. It sees that it's not one of the arguments, so it has to look outside the function for some variable called vars. And that was defined way up here, right here. Okay, so if you want the user of the function to be able to control which variables they print, you have to supply an argument for the variables. So let's copy this. Let's call it flight path 6 because we're not creative. And we're going to say vars. Okay, there's different ways to do this. For something like vars, I'm just making room here. For something like vars, you probably want to supply default variables because, you know, if someone else is using your function, they're not going to know which variables are in there. So one way of doing that is the following. Let me just grab this. And I'm going to remove tail number. Okay, so from a style standpoint, this has become a bit of a mess. So let's just put these on their own line and that there. Okay, so this is perfectly fine. What are we calling this? Flight path 6. And vars there. And all that stuff. Okay. So we can do this. Oops. Flight path 6. Okay, that's our function. We can call it. Let's see. 303NV. What's happening here is it's printing out the thing that got returned because we didn't assign it to anything. If instead we had done this, it would not print anything. We can say flight path 6 true to print something. And then we can also supply the variables we want to fit. So we want to add, so bop, bop. True, and say we just wanted departure and arrival. So when we call the function, they're going to get assigned in order. This gets assigned to tail number, this gets assigned to print path, and this gets assigned to vars. Okay, so that one, let's do an assignment so there's not too much getting printed. Okay, so now it's just printing depth time and arrival time. Okay, now from a style, so this is perfectly fine. From a style standpoint, you'll probably see something like this written in the following way. So you'll probably see this in the body. And the reason is that this is just a lot of stuff in the arguments to the function when we call it. So you'll probably see something like this. All right, so the default value now for vars is null. So inside the function, you're going to have to say if is.null vars. So if it's null, then we'll assign some default values. And then we'll continue on our way. If this thing is not null when the function is called, in other words, if the caller of the function has given some variables, then it will just skip this and keep them as they are and then run the rest of the code. So for whatever reason, people who write R functions tend to do this. It's probably just a style thing because then in the function definition, you don't have this big long thing that we saw before. So you'll probably see things like this when you read functions. But this one will work exactly the same way. If we don't give it this argument, the var's argument, it sets to null by default. Then this evaluates to true and it defines it. If we do give it an argument, is.null evaluates to false and that doesn't get overwritten. So it does what we want it to do. Okay, so all of these functions are returning something, but one limitation is that a function in R can only return a single object. So if you wanted it to return multiple things, the example we're going to look at is to have it return both the indices and the distance traveled by the airplane. You have to use a bit of a workaround, and that workaround is to have it return a list. So let me just show you how that works. I'm going to take this one and copy it, and I'm going to simplify things quite a bit here. So we're just giving it a tail number. We're not going to worry about printing. But what we are going to do is compute the distance traveled as the sum of air $distance. And it shouldn't matter. When you add things up, it doesn't matter which order you add them, but I'll just do II ord. And right now, it's just going to return II ord. If we want it to return both the indices and the distance traveled, we have to have it return a list. So I'm going to have it return a list where the first element is called ins, and it's set to II ord. And the second element is called dist traveled, and it's set to dist traveled. That closes the list. That closes the return. And I need to call this flight path 7. Just making this a bit more compact. Run it, call it. The only argument is tail number. Okay, so now you can see what's getting returned is a list. You can tell it's a list because it has these dollar signs. And, well, you can tell it's a named list because it has a dollar sign and then the names. The first one is named ins. It's the ordered indices for this tail number. The second one is called dist traveled. And this one happens to be, I believe it's in miles, 5,280 miles. Which is kind of a coincidence. That's the number of feet in 1 mile. All right, let's see. 3, was this another one? Okay, here's another flight that went 5,000 miles. Okay, so that's how you would return multiple things. You still only return a single object, but if you make that object a list, it can have different fields for the multiple things that you want it to return. Okay, now that we've learned about functions, we're going to be doing something fun, finding the plane that traveled the furthest. But before we do that, let's recap what we learned. This is how we define a function. You have to give it a name, just like any other object in R. You use the function, and if you want to give your function arguments, you put them in as the arguments to the function. And then inside curly braces, after you close the function, you put the pieces of code that you want the function to evaluate. And one important concept is that of variable scoping. So when it's evaluating the code with various objects here, like for example, tail number, the first place it looks for that object is as an argument to the function. So in this case, tail number, it finds it is an argument to the function, so it'll use whatever was supplied when the function was called. If it's not supplied as an argument to the function, it looks in what's called the global environment. So it looks outside the function where the object air was defined, and it uses that value. So that's a really important thing to understand about functions, the issue of variable scoping. So we looked at what functions return. By default, it returns whatever is evaluated on the last line. But I think it's good practice to explicitly include a return statement to say what's returned. Just makes it easier for whoever's reading to quickly identify what gets returned by the function. We looked at including arguments with default values. So in this case, the print path argument was set to false by default. So when you call it without the second argument, it sets it to path. It sets it to false. We looked at some more options, how to control, in this example, what variables get printed, which included looking at including null values for arguments, just for style purposes. And then we looked at returning multiple things. Okay, so let's get on to the fun thing. We're going to try to figure out which plane traveled the furthest on this particular day. So what the strategy here is, we're going to loop over all the different tail numbers and calculate the distance traveled for each of them using flight path 7. So I'm going to define an object called unique tails, and I'm going to use the unique function on air $tail number. So this is the vector of all the tail numbers with repeats, since the same tail number will have multiple flights. Passing it into the unique function will give us the unique values. So in other words, no repeats. So those are the unique tail numbers. That's the thing we're going to be looping over. I'm going to define num tails to be the length of this. And then I have to have another vector that holds the actual distances traveled. I'm going to call that dist of tail. And I'm going to initialize that with missing values. And I'm going to use the variable I just defined. So, and I also want to name this. So names dist of tail is unique tails. The reason I'm doing this, and this gets back to what we're talking about having good variable names. I'm going to be able to say, once I'm done, I haven't written the code yet, but once I'm done, I'm going to be able to say, let me put it down here just to preview, dist of tail 303 NV. So since I'm naming dist of tail, I can access its elements with the name of each element. So what I'm going to do is I'm going to fill up dist of tail with the distances in the right order so that they correspond to the right tail number. Okay, let's jump into it. So I'm going to write a for loop, j in 1 num tails, looping over all the tail numbers. And I'm going to say dist of tail j. I'm going to call flight path 7 with unique tails j. And this function returns a list. So I have to grab, and you could do this, you could compound these. So I'm going to grab the dist traveled element of that list. Okay, so that's it. So let's see if it works. So unique tails, num tails, dist of tail, names, so on and so forth. Let's just see, num tails is 4,727. So So we're going to be calling our function 4,727 times. And let's run this loop. Took a second to run, but that was still pretty fast. And let's first do head dist of tail. You can see this is a named vector. We can access the elements by selecting the names. We saw this before. This particular tail number went 5,280 miles. And we get the same information by selecting the second element. All right, so let's see which one went the furthest. So we can call max. Okay, so that's telling us that some tail number went almost 24,000 miles. Let's do it this way. Let's say sort dist of tail. And as we learned before, sort will put the smallest ones first. So let's put the biggest ones first by saying decreasing equals true. Oh, and we don't want that many. Let's just print the first 10. Okay, those are the first 10. All right, so this one that went 2,996 has no tail number. So let's see what's actually going on here. So flight, what's our function? Flight path 6. I'm going to call flight path 6 with that tail number, because that's the one that's here, I believe. And I want it to print. And I'm just going to do the default variables. All right, so what's going on here is there's no departure time, no arrival time. So I think that these are potentially flights that just didn't happen. So I don't think there's a tail number that's empty that actually went 24,000 miles. This is just counting up the total distance of flights that didn't happen. So it looks like the longest one is this one. So let's do that one. Oops. That didn't copy. N, I'll just type it in, 779 UA. Okay, so that's the one. Let's see, 737 to 1851 from Guam. Okay, that makes sense. That's a long flight. Guam to Honolulu. And then it says 939 to 107, Denver to Honolulu. And then Honolulu to Chicago. So I'm guessing this is something weird in the data. This is an impossible flight path because it traveled back in time. Not only did it travel back in time from 6:51 to 9:39 a.m., it teleported from Honolulu to Denver to have this be the next origin. So I think that's probably... I saw some things in the data where it's actually a flight from the next day that gets reported this day because the delay was so long that it actually left on the next day. So I think this is not, well, it's definitely not a real flight path. So let's grab the next one. N373HA. Okay, those are the indices, and this is the path. So this says 1:40 a.m. to 5 a.m., Las Vegas to Honolulu. Okay, Honolulu to LA, LA to Honolulu, Honolulu to Las Vegas. Okay, that makes sense. And the times 5 a.m., 7:56. Yeah, this is a plausible flight path. And this was how long? 10,000 miles. That's a long day. Let's do one. N449. Okay, this is all right. This is a long day that doesn't go over the ocean. So Orlando, 6:58 a.m. Orlando to San Francisco, early morning flight. So this is I don't know, it's probably like a 5 or 6 hour flight, but time zones change. So this looks like it only takes 3 hours. This one eats up a lot of the day. Going east, San Francisco to Baltimore. Lands at 7:31 in Baltimore. Baltimore back to San Francisco. We gain time, and then there's a red-eye flight, I guess. 11:58 to 8:18 a.m. San Francisco to Philadelphia. And that, so what's that? 4 times across the U.S. was almost 10,000 miles. Okay, that's a lot of flying on one plane in one day. Okay, that's it on writing your own functions. It's really not that complicated, and it'll make your life a lot easier and make you a better programmer. See you next time.